Good morning. We are going to start chapter 5 today. I'm sorry, not chapter 5, unit 5. And as we begin unit 5, I just want to let you in on a little secret. Can you see the pack and play behind me? Can you see it right over there? There are puppies in there, little puppies. But they're sleeping right now. So that's just a tease. At some point during this video, I may hold up a puppy and lecture. Present with said puppy. So here we go. We are in unit 5. This is chapters 8 and 9 in your textbook. We're going to be looking at how to price your merchandise in a business and how to do a little bit of payroll. So today we're going to begin with chapter 8, section 1. This is markup based on cost. Our goals for today are to define some of the concepts. We want to make sure that you understand the difference between a selling price, what markup is, and what the base is. We'll look at profits and margins and what's known as the retailing equation. We want to understand and use this retailing equation in order to find the cost of an item, the amount of markup, the selling price, the three basic parts of the retail equation. We want you to be able to calculate the percent markup based on cost, calculate the selling price when you know the cost and the percent markup based on cost, and to calculate the cost when you know selling price and the percent markup based on cost. So basically 3 sort of ideas, and we're going to rearrange things. It's not so different from what we did before, where we had to know dollar amounts and then we went back and had to figure out percents. It's kind of the same thing. So the idea here is that when you have a business, your money flows out. In other words, it leaves your pocket because of a few things. The cost of the goods. To a manufacturer, this is known as production. And there are what are called chain costs. So if you think about it like a manufacturer produces an item, sometimes there are direct sales to stores, but oftentimes that item will go to another distributor, and that distributor will go to another distributor. There's an old Seinfeld joke about how Costanza is an importer-exporter. I work in import-export because they don't necessarily produce the items, but they might buy a bunch of them to bring them over to the States. So these are known as chain costs because the retailer, when we as consumers, we go in and buy them from retailers. It's not like the retailers necessarily made the items. They bought them from a distributor who maybe bought them from another distributor who maybe bought them from the producer and manufacturer of the items. So an item is probably gone through 3 or 4 other businesses before it even reaches you. All right. There are also what are known as operating expenses. Operating expenses refer to the ancillary or extra things that a business has to pay for, like salaries of its employees, the rent for the business, any utilities to keep that particular business or building open, taxes, whether that be sales tax, payroll tax, business taxes. There are all kinds of taxes all the time. Insurance, which is something most businesses have to keep. Insurance, not just on the items in their store, but insurance on things like what if somebody trips and falls coming into the store? And what if they say that you didn't mark the step well enough? So they could sue you in that case. So you need insurance for those kinds of things. There's also advertising the business, advertising the items that you have. That could be print, it could be television, it could be social media advertising at this point. So these are some of the costs that your business has to cover based on what you sell or bring in. So how does the money flow in? Well, the money flows in based on sales, and your sales have to cover all of those costs we just mentioned, and you want your sales to cover profit. Now, profit is the money that is pocketed after all other costs, all of those costs that we just mentioned, and overhead are paid. The profit is the difference between the selling price and the cost and overhead. So there are sort of we tend to think of it in terms of just two ideas, right? What everything costs you and what you can take home. But there's actually a category we don't talk about or think about much, which is the overhead category. And overhead is that sort of second column about money flowing out, all of those things that you don't necessarily think about, like utilities and other salaries and taxes and insurance and advertising. All of those are what's known as overhead because your business couldn't exist without them. We cover overhead and profit by doing what's known as a markup. This is the amount that is added to the cost of an item, and we ensure that overhead and profit are covered with that markup. In the early days of a business, oftentimes you can forgo any kind of profit and put it all back into overhead and or operating expenses. That is to say, once you've paid for all of your items, oftentimes in the beginning of a business, the rest of your money is going to go directly into maintaining that business and not so much into pulling a profit out of it, not so much into spending money. I think about someone I know who has just opened her own sort of salon. And one of the things when we were talking about it is that yes, she's making money, but the money she's making is essentially going to pay the construction costs for her new little space. And she finds that every time she thinks she has extra money, it turns out she needs to buy a new hairdryer, or her chair broke, or she's run out of color for her clients. So these are the overhead ideas and the running costs that can eat into what you thought might have been a profit, right? So the markup, which is the difference between the selling price and the cost of an item, is for sure a monetary amount. So it's a dollar amount, that markup. We can think of it as a percent if we look at it in relationship to the cost of an item, or we can look at it in relationship to the selling price of an item. In today's presentation, we're going to be looking at the markup as a percent or portion of the cost of an item. All right, so to begin, 8.1, we need to talk about what's known as a retailing equation. This retailing equation is the basis on which businesses operate. It's the whole idea that the selling price of an item is made up of the cost of that item plus any markup applied to it. Now, you will often see this particular equation, this overruling concept, written as SP is equal to C plus M, where SP is your selling price, C is the cost, and M is the markup. Now, your textbook gives you two follow-up equations. The cost is the selling price minus the markup, and the markup has to be the selling price minus cost. Now, some of you will prefer all of these formulas to be separate. I just see them all as a function of the first one. If I'm looking at selling price is equal to cost plus markup, and I want to find the cost, I will simply subtract the markup from the selling price. This gives me the formula, cost is equal to selling price minus markup. Similarly, if I'm looking to find the markup, I would do selling price minus cost. Again, I don't see any need for me to memorize or to know three separate sort of equations when knowing one and a little bit of algebra, which hopefully we've practiced and you understand, is just as helpful. Excuse me. All right, so a couple of relatively quick problems. So first problem is ceramic platters cost the manufacturer $6.80 per unit to produce. If a markup of $9.40 is added to the cost, what is the selling price of each planter? So our formula and overreaching concept says that the selling price has to equal the cost plus the markup. I know the cost in this particular problem is $6.80, and I know the markup is $9.40. So I just need to add those two together, and I get $16.20. So the cost per planter is $16.20. Now, second problem. After a wholesaler adds a markup of $75 to a television set, it is sold to a retail store for $290. What was the wholesaler's cost? So we can say that cost is equal to the selling price minus the markup. I have simply subtracted markup from both sides of that initial equation. To get cost is $290 minus $75, which is $215. Third one is just the other arrangement. Forest Hills, which is a golf course here in La Crosse, sells a dozen golf balls for $28.50. If they paid their distributor $16.75 for those golf balls, what is the amount of the markup? So if I'm looking for the markup, I can subtract the cost from the selling price. So markup is selling price minus cost, which would be $28.50 minus $16.75. This is $11.75. All right. Now, how do we find the percent markup? In this case, based on cost. So, a couple of things to start. Markup based on cost, which is a very specific realm for this. Markup based on cost is used by manufacturers and by wholesalers. This is their information on the cost of the item is readily available to them, and it's controllable to a certain extent. So if you're the one creating the item, if you're the one fabricating it, if you're the one producing it, you have some control, or your business has some control over the quality of the items that go into making that particular good, right? If you're the one making, let's say, lawn chairs for the summer, you can control the grade of aluminum that goes into those chairs. And so you have control over the cost of your item, because a higher grade aluminum would likely cost you more than a lower grade aluminum. Now, there's all kinds of other things that need to be figured into that, but if we're just looking at cost, you have control of that. You have control of how many webbings you put across the seat, right? You could just do 4 each direction, or you could decide to do 6 each direction. That's going to affect the quality of your item, but it's also going to affect the cost. And you have to make decisions on those kinds of things. When we look at the percent markup based on cost, what we're saying is that cost is the base. It is the 100%. Our markup is being compared to the cost of the item. Our portion, or the amount of the markup, is the markup rate times the base. So our percent markup is the rate, the dollar markup is the portion, and the cost is the base. This is our percent triangle. Do you remember our percent triangle? Where the portion, the amount of the markup, goes on top. The rate goes to the bottom, what is that, left? That is the percent of the markup. And the base is the cost of the item, the known cost of the item. This means that we can create 3 basic equations. The portion is the rate times the base. The rate is the portion over the base. And the base is the portion over the rate. Do you remember these 3? These 3 and that triangle from chapter 6. We've already gone through them. We're just going to be using them. All right, so 8.2 is finding the percent markup. We're going to introduce in this unit a new strategy. You may or may not like it. If you don't like it, just fast forward through those parts of the presentation. But it is a strategy that works all of the time. So I like it, and I'm going to show you how to do it. The strategy uses that retailing equation. The cost plus the markup is equal to the selling price. And it puts it in a column to the far left. And then you need 2 additional columns. One column is for the dollar amounts, and the second column, or third column in this case actually, is for the percentages. Because we are looking at a markup based on cost, the cost is the base and 100%. So since it's a markup based on cost, I know the cost percent is 100, right? I'm going to fill in the rest. And as I do, I will see some options. It could be that when I start filling things in, I have 3 of 4 in this sort of greenish square filled out. And then I'm able to make a proportion out of those 3. It could be that I get 3 of the 4 in this bottom of 4 section, which looks like red and then a little weird color there in the top. Or it could be that I end up with the top row and the bottom row, and I can build a proportion out of those. So it seems a little odd, but I'm going to go ahead and do a couple of examples, and I'm going to do them 2 ways. The first way is going to be using this particular, I guess it's over here, isn't it? Is it over here? I'm using this particular strategy, this particular chart, and then I'm also going to go ahead and do it using the formula, just so you can see it a couple of different ways and decide which one you like better, and then follow that method as we continue working through the presentations in this section. All right. The Lighting Center buys lamps for $45 and sells them for $63. What is the amount of the markup and the percent of the markup based on cost? Remember, everything we do in this particular section is going to be based on cost. So to begin with, I'm going to start with the lovely chart. Notice that the first column is cost plus markup is equal to selling price. My second column is the dollar amount, and my third column is the percentages. Because this is a markup based on cost, I'm going to put 100% where the cost is. So the cost percent is 100. That placement is automatic, and I know it. Then I'm going to go back and mine the rest of my information from the word problem. The Lighting Center buys lamps for $45. So I know the cost to the Lighting Center is $45 and sells them for $63. So the selling price of the lamps is $63. So that's the dollars are 63. What is the amount of the markup and the percent markup based on cost? So I only have these 3 pieces of information. But if we look at the dollar column, I have 45 for the cost and I have a selling price of 63. If I know the cost is $45, and I add the markup, which is not known, to it, I should get 63. So the markup is the difference of the selling price and the cost. So 63 minus 45 gets me 18. This is the markup amount. So the amount of the markup, already found. Got it. Okay. What is the percent markup based on cost? So the percent markup is the last thing I need to find. So in my markup row, in the percent column, because that's missing, that's going to be my X. And then I'm going to state that I did know the markup amount was $18. So I've got the markup amount is $18. Now, remember I had those little blocks. Do you see that you've got the first 2 rows here, the 45, the 100, the 18, and the X? With these 4 places filled, I can set up a proportion that says, and I'm going to take it right from the way those blocks are written, 45 over 18 has to be the same as 100 over X. This proportion now allows me to cross multiply. So I'll do 45 times X and 18 times 100. They have to be equal. So 45X is 1800. To isolate the X, I will divide both sides by 45, getting an X is equal to 40. This would be 40%, right? Because that X is the percent markup, and that's the 40%. Now, that's the way to use the chart. You can also use the formulas, the percent formulas that we did back in chapter 6. We know from the percent formulas that the rate has to equal the portion divided by the base. Our rate is the markup based on cost. The portion is the amount of the markup in dollars, and the base is the cost in dollars. So our markup based on cost is the amount of the markup divided by the cost of the item. Or in our case, 18 divided by 45, which when I divide that out is 0.4. That's not a percent. I do need to multiply by 100 to get the percent, and I get that the markup percent matches what it did in the chart. I get 40%. Out of order, but hey. All right. How do we find a selling price? Well, the selling price we said is cost plus the markup based on cost. Cost, we know as a percent would be all of it, so that's 100%. Our markup is the rate times the cost again. So one way to look at it is that our selling price is the cost plus the markup. We're going to have to pay 100% of the cost plus an additional markup based on cost. Do you see how both of these have cost in them? Yeah? So I'm going to do a little algebra, and I'm going to pull that cost piece out front. I'm basically going to undistribute it. Algebraically, it's called factoring, for those of you who are with us on that. But I'm going to pull that cost up front, and then what's left is going to be set in parentheses. So I'm going to have cost, and then in parentheses, I'll have what's left in the first part, which was 100%, the plus sign, and what was left in the second part, which is the markup percent. Do you see how cost is still out front again? I've pulled that out. This now is the formula for the selling price. So as a formula for selling price, we can say that since the selling price is all of the cost, 100%, plus the markup percent based on cost, in this case, because they're both costs are the percentages, we can look at that like a common factor, like a common denominator, and pull that out front, and then add the percents that are left, giving us the selling price is equal to cost times 100% plus the percent markup based on cost. And that's the formula for selling price, markup based on cost. So here we go. Costco purchases toasters for $9.40. They have a 65% markup based on the cost desired. What should Costco sell these toasters for? Well, we can use the chart and the proportions like we talked about before. Again, the first column is our big equation, cost plus markup is selling price. Our second column is the dollar amount, and the third column is the percents. Since this is a markup based on cost, we'll put the 100% where the cost is, and now we're going to mine the rest of the problem for data. Costco purchases toasters for $9.40. So the cost for Costco is $9.40. They have a 65% markup based on cost desired. So the markup percent is 65. And I can put that in markup and percent. What should Costco sell the toasters for? So my selling price is what's missing. That's the last row. And if I look at the percent row, I can see I've got 100 and a 65. I know from the overreaching equation that cost plus markup is equal to selling price. So 100 plus 65 is 165. And I'm going to put an X where the selling price dollar amount is, because that's what I have to find. Now, looking at this, I can see that I have the first row filled in and I have the last row filled in. Using those two rows, I can set up a proportion that allows me to solve for X. So I will have $9.40 over X is equal to 100 over 165. When I cross multiply, I'll do X times 100 and $9.40 times 165. This gives me 100X is equal to 1,551, or X is equal to 1551. Now, using the formulas, I want to see if I get the same answer. So using the formulas, the one we just saw, we see that selling price is equal to cost times 100 plus the percent markup based on that cost. So we do know our cost is $9.40. We know our markup percent is 65. So I'll have $9.40 is equal to 100% plus 65%. This is $9.40 times 165%, or 1.65, which is also $15.51. This gives us an overall selling price of these toasters of $15.51. How do we calculate the cost? We know from 8.3 that our selling price is equal to the dollar amount of the cost plus 100% times the markup based on cost. Or our selling price is cost plus 100% times 100% plus the percent markup based on cost. We can simply rearrange this equation for the cost by dividing both sides by the parentheses. That will put the selling price over 100 plus the percent markup based on cost. So our cost is equal to the selling price divided by 100 plus the percent markup based on cost. And this gives us a new formula. So how do we use this formula? All right, General Electric sells automatic coffee makers to their distributors for $13. A 225% markup based on cost is used. How much did it cost to manufacture this coffee maker? So if we use the chart and the proportions, again, in our first column, we have cost plus markup is equal to selling price. Our second column is the dollar amounts, and the third column is the percents. Since this is a markup based on cost, the 100% goes where the cost percent is. And I'm going to mine the rest of my data from the word problem. And I'm going to start that again. So General Electric sells coffee makers to distributors for $13. $13 is then our selling price. A 225% markup based on cost is used. So the markup is 225%. And that goes in the percent markup placement. Now, I've got 100% of the cost plus a 225% markup means overall you're paying 325% of that item's original cost. So that's a little over 3 times what General Electric bought them for. So if General Electric bought it for $3, you'd be paying closer to 10 for that item. A little bit more than 3 times the cost. But we need to figure out the exact cost. So we're going to put an X where the exact cost is there. And you notice again that we have the first row and we have the last row filled in. So with this chart, I now know I can set up a proportion that says X over 13 is 100 over 325 using those 4 pieces. Cross multiplying, I get 325X is equal to 1300, or X is equal to 4. I can do the same thing with the formulas. Using the formula, specifically the one we just talked about, I know that cost is equal to the selling price divided by 100% plus the percent markup based on cost, or 13 over 100% plus 225%. This is 13 over 325%, or 13 divided by 3.25. This is indeed 4. This tells me that the cost to manufacture this $13 coffee maker was $4. That's pretty good. I think I paid like 15 bucks for my last coffee maker from Target. Wasn't the best. It really didn't last me that long though. All right, so we're going to talk about the idea of keystoning. And what keystoning is a sort of quick and easy way to talk about your cost of an item compared to your selling price of an item. So when you keystone something, you essentially double the cost of that item in order to arrive at the selling price. So what that means is that you are aware that your cost is half of the selling price. This was really prevalent at a bridal shop that I worked at for, I don't know, a year or so in my early 20s. We knew that the dresses that were coming in, whatever the buyers paid for them, we were going to be selling them in the store for twice that. Since we were in a small town lacrosse boutique, basically the dresses that came in, we had to make sure if we picked them, we didn't have an official buyer. Like the owners picked dresses and some of the employees picked dresses, made suggestions as it were, because we were all young women in our 20s. But when we suggested a dress, we basically knew that if the cost to the owners was more than $500, it was likely it wasn't coming in. Like they wouldn't keep it on hand. Not that they would never sell it, but they wouldn't keep it on hand to try. So we knew that if we were going to look at a dress or suggest a dress, the dresses had to sell for $1,000 or less. And so that meant that we could only pick dresses that were $500 or less. Does that make sense? And that was sort of the idea of keystoning. So here I have a problem to go through. We have, you are a buyer for Harley, as in Harley Davidson. You want to buy jackets that you can keystone for $400 or less. So you want the dresses in store to be under $400, or the jackets in the store to be less than $400. So what is the most that you can pay for the jackets? In terms of your store, $400 should be twice your cost. So $200 is the most that you can pay for the jackets. At a trade show, you have found a vendor with a line of jackets, and they have a list price on those jackets of $280. The vendor has offered you discounts of 12, 10, and 5. Will this allow you to keystone those jackets at the price point that you initially stated, $400? So do you recognize the 12, 10, 5? The 12, 10, 5 is a series discount, and with that, we can find the net price factor. To find the net price factor, we need the complement of each of those. So the complement of 12 is 88, the complement of 10 is 90, the complement of 5 is 95. So as decimals, we're going to multiply those percents together, 0.88 times 0.9 times 0.95, to get 0.7524, or our net price factor. Our net price will be the list times that net price factor, or 280 times 0.7524, which is 210.672. Now, we've already said that you can't go over $200, and this would be 210.672. And so technically, you have to walk away. And then the vendor throws a wrench in things. The vendor has decided that the 12% discount is negotiable and wants to know what discount would allow you to keystone that jacket. So he wants to keep a sale. And so he's said to you, well, that 12% is adjustable. Like, we can negotiate that. And so rather than jumping back and forth, I mean, you could tell him 15, but is 15 enough? You could tell him 20, but is 20 enough? You want to go in with a little bit of knowledge. So you're going to set this up as $200, right, is what you need to be. And you know that's 280 times your net price factor. But what you don't know is what that first number needs to be. So we're going to do 200 has to equal 280. That's the cost of the jacket, times an unknown discount, well, complement, really, times 0.9 times 0.95. The 280 is what he's offering for the jacket, the list price for the jacket. The 200 is your budget limit. The X is because you don't know what that first discount has to be. You don't know if that's okay at 17% or 20% or 15%. You don't know what it's okay at. So we're going to put an X in there. Now, algebraically, I can move stuff around. And so I can do 200 is equal to, and I can multiply those numbers, 200 times 0.9 times 0.95, and leave that X. That gives me a 200 is 239.4 times X. And now I'm just going to divide both sides by the 239.4. to get x is equal to 0.83524. So I know that 83542 is the complement of the discount. So my discount has to be the complement, they have to add up to 100, of 0.83542. So 1 minus 0.83542, or 1 minus, or 0.16458. Multiply by 100 to get the percent, and we get 16.5. So I know now that this particular vendor would have to be willing to give me a 16.5% discount at least. Could I negotiate with him and start at 18 and see if he'll go down, or even 20? Yes, because now I know 18 and 20 will work. I haven't backed myself into a corner where I'm still not making budget. I'm actually aware of where I need to go so that maybe I can get an extra discount when I negotiate. I couldn't do it for anything more than 20%. Well, that's just more money in my pocket then, right? Because like we said last unit, the more discounts you can negotiate for yourself, the more money is going to go into your pocket. All right, this is the last bit of Chapter 8, Section 1. So let's just see if you feel confident. Do you feel like you can define the idea of a selling price, a markup, and what the base is? Are you okay with profits and markups and margins? Do you remember the retailing equation? Do you understand how to use that retailing equation to find the cost, to find the amount of the markup, to find the selling price? Can you calculate the percent markup based on cost? Can you find the selling price when cost and the percent markup based on cost are known? Can you calculate the cost of an item when selling price and percent markup are known? Okay. There is in your e-text some extra practice at the end of section 1 in chapter 8. The review exercises that can be done there are problems 1 through 25. I don't know the pages in a concrete book of what pages those would be on, but if you do have a paper copy of the textbook, you should see similar review exercises at the end of chapter 8, section 1. There is a graded assignment available on WebAssign. Again, that would also be chapter 8, section 1. And as always, if you have any questions or concerns, please don't hesitate to contact your instructor, the support personnel, the Math Center, or any tutors that you may have available to you. We are all here to help.